Hey guys, my name is Iman, and in this video I'm going to talk about one of the MATLAB GUIs that I developed for my research. It's called BBPW. It stands for Broadband Plane Waves. Before I explain the GUI, let me just talk about some of the concepts behind this GUI. Let's assume we have different plane waves coming from different directions. So that's one plane wave, that's another plane wave, and that's one more. So these plane waves are the information that we receive from a far-field object, for example, galaxies. And let's assume we have an antenna, linear antenna, and you can have as many sensors as you want. So if we receive these plane waves using this antenna, we create a two-dimensional signal. Why? Because we do sampling in a space and also we do sampling in time. So by receiving this information using these sensors, we are creating a two-dimensional signal. Now, it can be shown that if we apply two-dimensional Fourier transform to this signal, the region of support for different plane waves are different. So, for example, this is for this guy, this is for this guy, and this is for this guy. So the region of support is different, and the slope depends on the direction of arrival. So the idea is, if we want to pass information from a specific direction, all we need to do is to design a filter whose passband include this guy and a stop band include the others. So in fact, by designing this filter, we can pass this guy and we can reject the other plane waves. So that's called beamforming. Now, if you're interested to read more about this concept, please read this paper, which is published in 2008, or you can read my paper, which is published in 2013. Now, let's go back to the GUI. On this box, you can define 5 different plane waves. As you can see, we have different direction of arrivals, and also we can have time delays to distinguish between different signals, and in this example I'm considering the same amplitude. Nx is the number of sensors, Nt for the filter is the number of taps for the filter, and this is number of samples for the signal. So these parameters are for the trapezoidal filter. So before we talk about the filtering thing, let me show you the two-dimensional Fourier transform for these plane waves. As I said, the region of support is different. Now, if you look at the two-dimensional Fourier transform, as you can see, they are different, and it's symmetric around the origin. So we have 5 different signals, comes from 5 different directions. Now, the idea behind beamforming is, if you want to pass this plane wave and reject the other, you need to have a trapezoidal filter whose passband include this guy and a stop band include the other. So if you apply this filter to these plane waves, as you can see, we pass one of the plane waves and we reject or we attenuate the others. Now, if you want to improve the quality of this filter, you can have, I don't know, more sensors or more taps in time. As you can see, the quality is better. Or if you want to improve selectivity, you can decrease epsilon. Final output. So basically there is a trade-off between quality and computational complexity. As you have more sensor and more taps for the filter, the computational complexity goes up, but the performance gets better. I think that's it. Thanks for watching this video, and please send me an email if you have any question. Thanks.